Hello. So we are at the Vitess maintainer talk. Today we're going to deep dive into one of the most important, one of the very important module of Vitess. Initially, I'm going to start with a very quick intro to what Vitess is. And my name is Rohit Nayak. I'm a maintainer. I work at PlanetScale. I've been maintaining Vitess for about 5 years.
And I'm Shlomi with PlanetScale, also maintaining for 5 years, and a contributor in the MyScale community. I authored Ghost, Orchestrator, and other open source tools.
Yeah, so originally Deepthi Sigareddy, who was our tech lead, was supposed to do what I'm talking about now, but she had some personal issues. You can land at the last minute. So what is Vitess, right? So that's a question that many people have been coming and asking, and we find it slightly surprising because if you use Slack, every message of yours is actually being stored in a Vitess cluster. If you use Git, create PRs, issues, they're all going into Vitess. Play Activision games, every bullet is going into Vitess. Vinted, Shopify, Etsy, many of these, HubSpot, right? So Cash App, if you're from the US, that's entirely in Vitess. We run, like Slack runs over 3 million queries a second. Vitess was one of the reasons they survived COVID very well, when suddenly everybody is working remote. So it's proven at level, but all of you are probably indirectly using it, but you don't know about it. So that's why I wanted to make a point here of talking about this. So it originated in Google, in YouTube, and it was serving all the metadata for YouTube for a long time, until Google finally, when they bought it, moved it over to Spanner, and then they open sourced it. So it's got Apache 2 license. There are a lot of contributors from all over. One of the key decisions that was made, because they were already running MySQL servers, that to continue to use MySQL as a storage layer. So unlike many systems who invent database layers, not that they're bad, but you already get something that you know, especially if you have used MySQL, and we don't have to worry about that part of it. What we do is we take multiple of MySQL clusters, give you a distributed option, make it distributed. And so it's massively scalable. I mean, you can just see if all these users are using it. High availability is also really important. So there are 3 things that make it highly available. Yeah, what I forgot to mention earlier was it was Google, when they bought it, they ported it over to Borg, Google Borg, which is a cluster management system, which actually is the inspiration for Kubernetes and Docker. So this has been cloud native from like very early days. So you get Kubernetes scaling. The architecture is there's a lot of microservices. You can scale them separately depending on your requirement. MySQL, of course, already has a replication, so you can use that. And Vitess adds something really important, which is very special to Vitess, is sharding, horizontal sharding. There's also, you can do vertical sharding, but that's easy. Horizontal sharding, where a table sits across multiple MySQL servers, right? Parts of it. One row is only one shard, and Vitess provides configurable sharding, right? So many databases talk about auto sharding. It works for some workloads, no problem, but for many of our customers, for many workloads, as you scale, you need, depending on your workload patterns and the kind of queries you run and the kind of apps you build, developers you have, you need to configure how you shard your data. And Vitess does that very well. You can change your sharding at any time. There is zero time, downtime cutover built in through various complex mechanisms. You don't really have time to go into that, but we are going to be at booth 1B in the north for some time, maybe today and tomorrow. So meet us up there. There's also a lot of things for operability that is there for backups, maintenance if you want to upgrade your versions, etc. Yeah, so a lot of people move to Vitess for scalability, performance, but there are also users who just use it for the module Shlomi is going to talk about, which is doing schema changes at scale. So it's a huge problem. I'll let him talk more about it. So over to Shlomi.
Thank you. All right. So we want to talk about how Vitess manages schema changes at scale. To do that, we need to discuss a little bit about the Vitess architecture. So I'm going to do a bottoms-up, real quick walkthrough about the architecture. So consider a normal MySQL replication topology. In this picture, you have one primary, 3 replicas. The first thing we're going to do is to add a tablet, which is kind of a sidecar or a daemon, attached to each of the MySQL nodes. So this tablet has control over the MySQL server. It can bring it down, bring it up, restore from backup. But most importantly for our discussion is that it controls all the traffic that is going into the MySQL server. The MySQL otherwise does not allow incoming connections, so the app never talks directly to the MySQL server. In production, you will have multiple clusters. Maybe it's a different database. For whatever reason, you have multiple clusters, and what we're going to put in front of them is Vitgate, which is a query engine and load balancer and query router and firewall, like all combined into one. And Vitgate is a component that masquerades as a monolith MySQL server. So it can speak the MySQL protocol, your app connects to that, talks to it, and thinks that this is actually the database, where behind the scene, Vitgate really talks to all of the underlying clusters. So in reality, we have many Vitgates, both for high availability and for throughput of queries, just to have enough capacity to serve everyone. Rohit mentioned that Vitess is a sharding framework, and this is something we're going to discuss in length today. So you might have some databases that are unsharded, but some databases are just too large, and you shard them. So there will be multiple shards, and for different databases, and some databases are unsharded. And the question is, okay, so how does my query go from here to there? How does Vitgate know if I'm going to query use commerce select star from orders using customer ID equals 4, how does it know that it needs to go to this specific database on this specific shard? And the answer is that we have a sharding scheme, right? A sharding configuration. It's stored on a non-data path topology server, as we call it. It's basically an etcd. And it's a very small footprint in memory just to define the routing rules for the entire cluster. And once Vitgate starts, it loads the data into memory, and from there, it's not in the data path of your queries. Okay, so far? Okay. So schema changes is a big problem in the MySQL world. If you're not familiar, if you have a table that is really large, you have a gazillion rows, like a billion or more, altering a table, like adding a column or modifying an index, is a process that could potentially take hours or even days. During that time, the table will be locked such that you cannot read and you cannot write to it. So it's kind of an outage situation. Now, MySQL does support some online operations and some instant DDL, which is really fantastic, but it's limited. It's a subset of all the operations that can be done on the table. And this is the reason why you will find online schema change tools in the MySQL landscape, such as Ghost, PT Online Schema Change, Spirit, and others. Vitess also implements an online schema change mechanism, and all of these tools kind of work in the same way. The idea is this. You have this huge, massive table. There's millions and millions and millions of rows in that table. Now, you want to modify it, but we know that this is a blocking operation. So what these tools do, they create a new table, we call it the shadow table, in the likeness of your original table, but it's empty. Now we alter the shadow table, which is a cheap operation because the table is empty, so it's no time. Then we start populating the shadow table from the original table. We both copy the millions and millions and millions of rows, as well as apply all the incoming traffic, all the change log that is ongoing. While we copy those millions of rows, people are still using the table, inserting, deleting, updating. We capture all that and apply that as well on the shadow table, until the two tables are in sync or in almost sync. And this is basically where most tools differ, but eventually they all do kind of the same thing. They make sure that the tables are in sync. They do a short stop the world. They lock the tables. Right now it's a situation where you cannot read or write from the table. And then they flip them. They just exchange one with another. So the app was just a second ago writing to your original table, but all of a sudden it writes to the new schema, right? The new table. And after a while, you can throw the old table to the garbage. Okay, so far? So this is a big problem just for a single large table, just for an unsharded database, just for a normal MySQL setup. Now we want to discuss how this problem becomes even more complex when you want to manage multi-sharded databases. So, as a quick reminder to the architecture, one of the most important attributes of this architecture is that the different clusters that you see them, there's 3 in this picture, they know nothing about each other. The 2 shards above, they don't even know that they are shards. Like the MySQL server that has tables and rows, it doesn't know that it's part of a greater game. It's not aware that there's another complementing server that has the rest of the rows. As far as MySQL is concerned, that's the data. It's up to Vitess to juggle and operate all this data. All right, so let's begin with a few aspects of what it means to apply changes to a sharded setup. We begin with idempotency. So let's say I have this table, I want to add an index. I set a DDL strategy to say Vitess, which kind of means do it the Vitess way. Don't do it the MySQL way, do it the online schema change way. And I issue an alter table add key. Previously, we saw that Vitigate, when I do an update table or insert or delete, we saw that Vitigate would send the query to the appropriate shard only. But now, we really wanted to send to all of the relevant shards. So if I have 64 shards, if my table is so big that I split it into 64, we need to inform all 64 shards that we want to update this table, to alter this table. Quite the task. What I get in response, in reality, is a job ID. But that table is not yet modified. Vitigate merely announced to the tablets that here is a request. Each tablet on the primary shard, or the primary of each shard, took note, said, oh, okay, I received the request. They each, in their own good time and independently of one another, spin up this online schema change mechanism that we illustrated later on. So for me as a user, I just issued one query, but there's now 64 different shards who are operating it. So the first thing I can do, or I want to do, is to get visibility. Like, okay, well, what's going on? Like, it's the problem times 64. So I can issue a show Vitess migrations command. That command, again, gets sent by Vitigate to all shards, and they each return one row. What's the status of the migration? On me. This is, I am shard 0408. And the migration is completed as of 12/21. Each shard will report a status. Hopefully, they will all complete. I, as the user, am happy, and we can continue with our life. But what happens if 2 of the shards were unavailable for some reason? Because computers, right? Life is tough. And I've sent a request to alter a table. 62 shards received the request, began the work, maybe even completed it, but 2 of the shards never got the request in the first place. Now, if I only have one table, one cluster or one server, no problem, I would run the command again. But I can't run the command again now because 62 shards already have that index. It will either be a syntax error or an error to re-add that index, or it will add a second index. It's crazy, right? So this is where idempotency comes in. It's nuanced. There's several ways to do that. But essentially, if I could take this UUID that I got earlier, this job ID, and resupplied it, then any shard that receives this command says, oh, wait, that's a job ID I've already processed. I know this job ID. I don't need to start it again. This is right. This is a no-op. I'm giving up. I'm saying, okay, I'm done. I'm happy. You don't need to ask me anymore. But the two shards that previously never got the request, they will see that as new and will start processing it. There's another technique. It's designed to solve something else, but it's very useful in this scenario as well, and it's called declarative migrations. So Vitess supports the idea of a declarative migration where you never specify, you never say alter table. All you say is create table and drop table. Now, if a shard receives this create table statement and the table does not exist on that shard, it's created, it creates it, no problem. If the table exists and looks exactly like this, okay, it's a no-op, everything is good. But if the table exists and has a different schema, maybe the index is different, the column is different, then that shard, each shard independently computes what would it take to get from the existing schema into the new schema. So it will devise the alter table statement, which you can see at the bottom here. Each shard will devise the correct statement that will get you to the new state. And it's kind of the Kubernetes way, right? You don't deploy a change, you deploy a state. So even if you get into this weird limbo situation, which you shouldn't, but even if you are, and you're not sure, and different shards are different schemas, okay, that's still okay. You can deploy a declarative migration, and each shard will independently make sure that it goes into the desired state. All right. Our next problem is consistency. If a migration takes hours to complete, different servers have different workloads, serve different traffic, run on different hardware, have different noisy neighbors. They will complete the migration at different times. It's certainly possible that different MySQL servers will complete this migration even hours apart. And it's okay, but it's undesired. It's undesired because it's confusing, because at any point in time, different shards will present different schemas. It's confusing to some scripts, which are not, the most sophisticated ones. It can be confusing to an engineer, a developer that goes into the database. They say, oh, there's the schema, there's the new column, I can start using it, great. But no, because on another shard, that column still does not exist. So it's unhealthy. Ideally, we want all the schema to be the same all the time, across all the shards. And there's a way to do that. Not atomically. That's not possible, at least with MySQL. It's impossible to change the schema atomically at all the shards at the exact same time, but we can get pretty close. And the idea is to postpone completion. So I set that as a DDL strategy. And if we get back to the way online schema change works, I copied the millions and millions of rows. I've tracked the changelog, the incoming traffic. I brought the tables up to sync. Nothing really compels me to cut over at that particular time. It's okay if I stall a little bit more, if I continue to track the ongoing changes and continue to keep the tables in sync live. Make sense? All right. So it's possible that one completes first, or one of the shards backfills the table first, but it will not cut over automatically. It will continue to apply the changes, and I will make it so that it only completes when all the rest are complete. So the way this works is I will issue a show Vitess migrations. One of the columns that they return is ready to complete, which will be either 0, like, oh man, I have many more rows to copy, I'm not there yet, or 1, meaning, yeah, I'm generally up to date, I'm okay, I can cut over whenever you tell me to. So again, if I have these 16 shards in this example, I will issue this query. If all shards respond with ready to complete equals 1, then I can issue an alter Vitess migration complete. This statement again gets pushed to all the shards at the same time, concurrently, and they will each do their best to cut over as soon as possible. And in effect, in production, in our experience, this means up to a few seconds between the first shard that actually completes to the last one, which is not bad at all in terms of relational databases and the behavior of applications. Some shards can be victims to an abusive query that maybe an ETL or something heavyweight that is inserting tons of rows or selecting tons of rows and is kind of preventing them from cutting over. That can happen, which can create a time gap for that shard. There is another way to ask Vitess to be more brutal about it. So it will forcibly terminate any queries or transactions that are holding locks on the migrated table just ahead of the cutover. So in a way, paving the way for a successful cutover. Okay, so far? We mind blow this when we explode in another dimension. First, we exploded the dimension of shards. But now we also say we can apply the same logic for multiple concurrent migrations across all shards. So Vitess allows you to run multiple migrations concurrently. And some of the stuff will be truly concurrent, some will have some sequentialization or serialization between them for performance reasons. But essentially the same logic applies. You will run all these changes together. This is, it's like a user is doing a pull request and they're doing multiple changes in multiple files, but those changes make sense together. The same way some changes to tables make sense together, right? So you deploy all these changes. This query will go in parallel to all shards. Each shard will say, oh, I received request 4, 5, 6, 7, 8 migrations. We'll apply them all at the same time. I will provide a postpone migration, and then I will issue a show Vitess migrations and wait for all shards to say ready to complete for all migrations, and then I will issue a complete all command. Boom, all shards will start frivolously cut over, one after another. Again, our experience shows, don't overdo this. Don't do like 30 massive tables at the same time on 128 shards. But if you don't overdo it, you can still expect a difference of seconds, maybe 10, maybe 20 seconds from the first table completed on one shard to the last table completed on a different shard. Okay. Last, I want to talk about resiliency. So question, I have two systems. In one system, I have 5 servers. In another system, I have 50 servers. Which of these two systems is more likely to see a server failure? 5 or 50? 50, correct. A lot of people would get confused. The more servers we have, the more likely it is that any single server will exhibit a failure. Of course, it's up to a good infrastructure to make a failure in a 50-server setup less of an impact as compared to a failure in a 5-server setup, right? Now let's look at schema migrations. If you use an existing online schema change tool, and let's say the migration takes 5 days, but after 2 days, the MySQL primary crashes. You have just lost 2 days of work. You will fail over, do whatever it takes to fix the MySQL, fine, but you will have to restart the migration and redo all of these 2 days worth of work. This is with one server. What happens when you have 64 shards? 64 different servers running the migration. 63 of them are happy, but after 2 days, one of them fails. Now, technically, it's only that one that needs to be restarted, right? But remember, I really like to cut over all of my shards together. So what happens is that 63 shards will have to stall for 2 extra days, all waiting for that one to catch up. And the more shards I have, the more probable it is that I will be in this situation. So Vitess doesn't fall for that trap. Vitess uses v-replication like one of the most important key components of Vitess, which is an auditor of data transfer, so to speak. So when it copies rows, either like the millions and millions of rows that it copies from the original table, or when it applies the changelog, using the same transaction where it applies the change, it also audits the metadata of the change, like the range of queries, the range of rows that it just copied, or the position in the MySQL binary log. It's a journaling system, which means the migration is stateful. If a primary dies, Vitess promotes a new primary. That primary looks at its own database and says, oh, I recognize there's an interrupted migration. This is the state of the migration. This is the precise point where it was terminated. It is able to adopt the migration and pick up from the very same point of interruption, which means you haven't lost 2 days. You've lost less than 1 minute. The time it takes from the moment of failure to the failover to the point where it adopts the migration to the point where it resumes operation. And so, to summarize the schema migration story in Vitess, frankly, I think it's better than the non-sharded scenario. Vitess automates so much on your behalf. You can run as many changes as you want. You don't need to run them one by one. You can run them together. You don't need to worry about failures because they self-recover. You don't need to worry about schema changes being different because you can control the cutover. You can decide to cut over not during the weekend, but by the time you're back at the office on Monday, after you've had your coffee. So you're a lot more relaxed about how the migration is going to behave in this multi-sharded environment. And we and the users, the Vitess users, are like so able to migrate tables that are terabytes of data and which serve millions of queries per second. Part of them reads, of course, but many of them are writes, without having to worry about it. Vitess manages all this, takes the traffic into consideration, takes replication lag, the load on the service into configuration, and just smooths the entire operation. All right. On the topic of roadmap, so Vitess is an open source project. We maintain it. We have thoughts for the future. There's always things to do. And to the large part of it, this is affected by the community or just, as a user, you need a particular thing. You find that schema change requires something. We just had great ideas from some users during this conference. We always have a roadmap ahead of us. We do 2 releases per year. And you are very welcome to join us in the Vitess Slack, to ask questions, to make suggestions, open issues on GitHub, read the code, read the documents, read our blog posts. I'm happy to answer questions if I have the time. All right. We will be here tomorrow. The Vitess booth will be open in the project pavilion between the hours of
12:30 to 2, but I'll be
Okay, so again the hours?
12:30
to 2 p.m., the project pavilion. Questions, sir?
Yes, thank you very much for the presentation. I think you did a fantastic job explaining all the complexity of running schema changes at the scale.
Thank you.
I have two questions, if I may. The first one is about safety of the safety checks. So there are certain situations where doing an online schema change may lead to data loss. A common example is having a unique index, deleting one of the rows that was part of the unique index, and now once you are inserting rows into the shadow table, some of the rows are dropped because those rows are not unique anymore. Another example is changing a column that is part of a unique index, and so on. So is there any plans to add these safety validations into Vitess itself, or is it the responsibility of whoever is using Vitess to run the safety checks?
This is an excellent question. Thank you so much. So this is being addressed. There's multi-layers to the answer. So Vitess works in the Unix philosophy, right? We give you the building blocks, you write the commands, you run the command lines, the flags, and you're responsible to manage this. And if you do, then there are answers for you. Now, if you remove a column from a unique index, then indeed, as you say, on the target table, there is less uniqueness, right? You can insert something that you couldn't insert originally. But how would it get there? It would only get there if you insert the row originally on the original table, right? The problem is different. After you cut over, then suddenly on the new table, you're able to insert 2 rows where previously there could only be 1. Is that correct? Let's put it a different way. If you have a table with no unique index and you add a new unique index, and the constraint fails because on the original table you have 2 conflicting rows, the entire migration will fail. Okay. However, I want to add to that. Vitess offers a mechanism that is called reverts. Revert says, once we cut over, at the time of cutover, if you remember, we do a stop the world. We record the position where we cut over. After cutover, if you're unhappy with the new table, you can issue a revert migration. And what we do is we use the same verification mechanism to propagate the changes back from the new table to the original table, so that you can cut over back to the original table, but still maintain all the new rows you inserted or updated or deleted, right? So you can go back to safety. The issue of unique is that is the point where maybe you're now, you messed up your data, it's not applicable anymore because you messed it up. Maybe you incremented from a tiny int to a big int, and now you insert a gazillion, right, a billion. You cannot move back to the original table because that number cannot be applied to a tiny int column. So there is indeed a measure of, you need to own that change. There is a measure of that. Part of Vitess is, there's a library called Schema diff, and there's actually a blog post on both the Vitess blog as well as the PlanetScale blog that describe how you can use it to find out about risks when comparing 2 schemas. So it's an advisor that tells you, oh, just for you can lose data during this migration because, I don't know, you dropped a column or reduced the scope of a column, or you can lose data because you reduced uniqueness or introduced uniqueness. So this is another tool that you can use.
Thank you very much. My second question, really fast, is so you show an example of particular MySQL syntax that could be applied, the alter table and all that. Is there any particular MySQL native syntax that cannot be applied to Vitess, like foreign keys or something like that?
Right. Foreign keys is the example. The problem is with how MySQL manages foreign keys. In particular, MySQL does not know how to manage foreign keys. The only element in MySQL that knows about foreign keys is InnoDB. And the way this works with InnoDB is that it is impossible for you to replace a table without touching the foreign keys, like and keeping them in place. So we do have a public fork of MySQL where we fix that, but you will need to use that particular version of MySQL. And then there's a -- unsafe allow foreign keys flag, which allows you to do that. Without this, foreign keys are not possible. Yes.
Hello, thank you for the talk. I have a small question. I think I missed it when you explained how is the migration completed. So the swap, the synchronized swap, is it a command run by engineers or tooling?
So it's run by the tooling. You don't need to worry about it. I mean, you need to worry about it because it's a bit of the risky or dangerous last moment change. The command is basically merely a rename table A to B and B to A, except it involves table C in between because you need to rename table A to C, B to A, C to B, right? That's the command. And the challenge for the tool is to make sure that, one, before running this command, the tables are actually in complete sync, or else this is wrong, right? And two, that it is able to acquire and complete the cutover, to acquire and complete the locking of the tables. So there are safety mechanisms that say InnoDB lock wait timeout, so that if the tables cannot be locked for the rename, the entire process of the swap fails and you roll back, and Vitess tries again in a few minutes and again in a few minutes, but it maintains integrity and consistency of the data.
And so it's always Vitess that triggers it. It's never an external command. I thought you mentioned or didn't say, I understood that like engineers chooses the moment where it's completed.
You can choose the moment, but Vitess does it for you. So you choose the moment, what you can say is postpone completion, right? -- postpone. Start the migration, but don't ever cut over automatically. And then at some point you will show Vitess migration. You will see that Vitess is, generally speaking, ready to complete. You can decide to go on a vacation during that time and say, no, keep running, please, I'm busy, I'm skiing right now. But once you're back from your ski vacation, you sit at your desk and you say, well, you know what, I'm ready, cut over now, please. And then Vitess will say, oh, okay, yeah, I've been keeping up, now I'm ready to cut over, I'm doing this. Sure. There's more questions, but no time, so I'm happy to take questions outside and give the room to the next speaker. Thank you so much.